Let's begin by identifying the main parts of the G3. The upper seal. This helps maintain a vacuum and assists in removing air from the injector. The lower seal helps inject resin into the damage, and the piston seal keeps resin isolated. The white seal at the end of the injector seals the injector to the glass. The handle actuates the piston inside the injector body. The cap attaches the piston assembly to the injector body. The piston is the main performer in creating and maintaining a vacuum and injecting resin into damage. The resin piston itself is used to assist in injecting resin into the damage, and it keeps the resin isolated from contaminants. The injector body is where the vacuum is created and maintained. All of these parts come together to form the G3 ProVac. A fundamental function of the G3 is its ability to remove the air from damage. Let's see how this works. As the piston moves up and away from the glass, a strong vacuum is created that pulls air out of the damage and into the injector body. When the lower piston seal disengages from the lower chamber, the air can then bypass this seal and move into the upper chamber of the body. As the injector moves into its pressure cycle and the lower seal re-enters the lower chamber, you might think that the upper seal will push the air back down towards the lower piston seal. This does not happen because the upper seal is collapsible. The top edge of the lower seal collapses inward, which allows the air to push past it and remain in the upper chamber. Then on the next vacuum cycle, the air is pushed out of the injector body since it cannot pass the one-way collapsible seal. The air moves past the cap and through the piston threads to evacuate the injector. The unique design of the G3 also allows for resin isolation. What does this mean? In this cutout, notice that the amber resin is in the resin chamber. Notice that as the vacuum cycle occurs, the resin stays in this chamber. Any air that is pulled from the damage moves around this resin chamber. Since the air and moisture from the damage did not come in contact with the resin, which is safe in its isolated environment, contaminant-free resin is then injected into the damage. But why is a strong vacuum and resin isolation an advantage to the technician? A strong vacuum will allow the complete removal of air, and in conjunction with a heat source, a vacuum allows moisture to quickly evaporate from the damage and move into the upper chamber. This allows for resin to be injected into a relatively pristine damage that will repair with more strength and less visibility. And since you've gone to the trouble of making the damage as contaminant-free as possible, resin isolation allows for the resin to remain contaminant-free. Instead of moving all of the contamination from the damage through the resin isolation means that these contaminants move around the resin, allowing for clean resin to be introduced into the damage. This means a stronger and less visible repair. The strong vacuum along with the resin isolation makes the ProVac G3 injector completely unique.